In this video for Computer Science 9618, we're going to take a look at a past paper 4 question. This topic focuses on a circular queue. So we know a queue is an abstract data type. This one, how to implement a circular queue. We're also going to walk you through how to fill out that evidence document. So let's go ahead and get started with what is a circular queue. Think of a sushi conveyor belt. Well, what in the world does that have to do with the circular queue? It works just like a sushi conveyor belt. It is like a circular queue. The sushi rides on the conveyor belts, and when it reaches the end, it doesn't fall off the conveyor belt. It circles back around to the beginning. Now, the sushi is the data, and when it's put on the conveyor belt, it's added to the circular queue. We call this enqueue or enqueuing. When a person takes a plate off the conveyor belt because they want to purchase it and consume that sushi, we say the data has been dequeued. The benefit of a circular queue is you can reuse open spaces in the queue because it doesn't end. It circles back around to the beginning. If it's not circular, it may need to expand indefinitely. So it's not always going to need to, but it may need to. Here is a sushi conveyor belt. I got this off Wikipedia in case you've never seen one. This is a massive one. You can see all the customers are around. And this conveyor belt just goes around and around and around. It doesn't end. You'll also see that people are enqueuing data. They're adding data to the queue, and it goes around and around and around. Anywhere there's an open spot, they can add new pieces of data. The consumers, when they want to take an item off, they're dequeuing the data, which means they're pulling data out. We have an open spot that we can reuse. So let's go ahead and let's take a look at the first part of the question and start coding it out. A business sells a single product. Customers can purchase one or more of this product. Each cell has a ID and a quantity, for example, ABC and an integer data too. The business needs a program to store the data about the cells in a circular queue data structure. Write program code to declare a record structure, cell data to store the data about each cell. Before you run off to VB, notice here, they're looking for a record structure. They're not looking for a string and an integer. They want a record structure or a composite data type called cell data that is made up of a string and an integer. So we're not going to have a string and integer data type. We're going to have a cell data type, which is our record, and the cell data type is made up of both a string and integer together. So make sure you do that. But let's swing over to VB and let's code out this cell data record structure. All right, we're in VB, so all we're going to do is go right up here to the top. We're going to do public structure cell data. Now, VB doesn't have records, so when we create a record, we use public structure cell data. Now, what does the cell data data type consist of? Well, it consists of cell ID, that is a string. It also consists of quantity, and that is an integer. Just like that, we have the code we need. What we need to do now is paste our code into the evidence document. Your evidence document will be provided to you by the testing center. You need to fill out your candidate name, your center number where you are testing. If you do not know your center number, should be displayed for you, as well as your candidate number. If you're not sure what your candidate number is, you need to ask your Cambridge coordinator right away so you can have that information, because you're going to need it when you go to assess. For those of you that have gone through Cambridge testing before, you'll already have your candidate number. So screenshots or program listings must be copied into appropriate cells in the following table. Save this evidence document as evidence underscore followed by your center number underscore your candidate number. And here they give you an example. Make sure you insert your name, center number, and candidate number, just like I told you, into this header. Do not try to edit this document. All you need to do is simply copy and paste code. Then it says examiners must be able to read the contents, including any screenshots, without the use of a magnifying glass. Answers that are not readable or are missing will not be awarded any marks. When you are pasting into this Word document, you want to look down here at the bottom right corner. Make sure it's on 100% because that way, when you are looking at your screen, you'll see exactly what the examiners see. Save this evidence document at regular intervals, for example, every 10 minutes. Make sure you do it. I would do it as soon as you paste in some code. I would save it right away. If you are testing on a laptop, keep an eye on that battery level. If your battery starts to drop, you need to let them know so they can provide you with a charger right away. If you're working on a desktop, you're not going to have that issue. Now, we're looking at question 2. So here's my evidence document. What I need to do is I need to scroll down to question 2. So here's question 2, part 2A. It's going to have this pre-filled text in here. I like to get rid of that. Do you have to get rid of it? Absolutely not, but it doesn't need to be there. What I'm going to do now, so I'm going to switch back to my code. And then what I'm going to do is I'm going to use the built-in Windows snipping tool. It's built into every operating system of Windows. So what I'm going to do is I'm going to hold the Windows key, I'm going to hold Shift, and I'm going to push S. What that will do is it brings up the snipping tool. I'm going to highlight my structure code that I wrote. It's copied. I'm going to go back to my Word document and make sure I'm on part 2A. I'm going to hold Control. I'm going to hit V to paste it in. And there it is. They'll be able to read that without a problem. So we've pasted it into the right part of the evidence document. We're now moving on to part 2B. Declare a global array circular queue of 5 items to store the cell records. So we created that cell data record. We're going to be implementing that with a circular queue. Declare the global pointers, head and tail. Every queue has a head and tail pointer showing the next item to be dequeued and where the queue ends. Now, because we have a circular queue, when we reach the end, we're going to be swinging around back to the beginning of the array. Declare the global variable number of items. Initialize all elements of the array circular queue to an empty record where the ID is null, so no string, that's not a space there, 2 empty quotes, and the quantity is -1. Initialize head, tail, and number of items to 0. Now, what you want to pay attention to here is head, tail is initialized to 0. That means we need to use index 0. If we omit index 0 and we were using the array indices 1 to 5, we'd have to initialize head and tail to 1. Otherwise, and it wouldn't work appropriately. So make sure you pay attention here because head and tail are being set to 0 and they tell us to do that. We have to include index 0. Let's swing over to VB. Let's code it out, copy and paste that code into our evidence document. Okay, when you declare these global variables, make sure you're outside the structure. It is not part of our record. So we're going to make that circular queue. Now, our max index is going to be 4. Now, that's going to be cell data. That is part of our record that we are implementing. Now, I just deleted a bunch of stuff. If that happens in your exam, just Control Z, and that will undo what you just did. You don't want to, get stressed out there. Head is going to be an integer. Our tail is going to be an integer as well. We also need number of items. That is going to be an integer as well. Now, it does tell us what we need to set all of that to. So our head is going to be equal to 0. Our tail is going to be equal to 0. Our number of items is also equal to 0. It did tell us that they want us to initialize the circular queue. For I equals 0 to 4. Now, for those of you that are new to coding, you may be saying, well, if it holds 5 items, why do you only have 4? So 4 is our max index. We start at index 0, and when I count 0, 1, 2, 3, 4, those are 5 items in total. Now we're going to do our circular queue I dot cell ID is equal to nothing. That is what they told us to do. And then circular queue I dot quantity, they said they wanted that set to -1. So I have my code here. Going to go up just a little bit. I need to copy and paste my code that I just wrote. So I'm going to hold Windows, Shift, S. It's going to bring up the snipping tool. And all I need to copy is the code that I just wrote. I don't need to copy any other code. I go into my evidence document. I make sure I'm in 2B, and I'm going to get rid of this predefined text. I paste in my code, and there it is. And I'm going to scroll back up here just to make sure it's in 2B, and it is. So that's fine that it goes on to a new page. Now you may be saying, do I have to take a snapshot or screenshot of my code? You can copy and paste your code into this evidence document. I highly recommend you do not do that because it may not format properly. Here, it's already formatted for you. We have a black background with some colored items. It makes it a lot easier for your examiner to read. So my advice to you would be to take a screenshot of your code, selecting just the code that you just wrote and pasting that in to your evidence document. So I look at my evidence document. We see we're moving on to part 2C. The function enqueue. So we are talking about adding items to our queue. Takes a new record as a parameter. It's very important that you notice it is a record. That is the cell data type. So we're going to need to be using that. Inserts the record in the circular queue at the element pointed to by tail. The tail shows the end of our queue. It shows the next spot where an item can go. It updates pointers and other variables as required. It returns -1 if the circular queue is full, returns 1 if the record is stored successfully. Write program code for the function enqueue. Copy and paste the program code into part 2C of the evidence document. So let's swing over to VB and let's code out this function enqueue and then copy and paste it into our Word document. Let's make sure we're outside of our main program, sub main. And what we're going to do is we're going to write that function enqueue. Now it does accept a record. So by val, we're going to call ours new record, one word, as cell data. What is this function returning? It's returning a 1 or a -1. So the return data type is going to be an integer. Now the first thing I want to do is I want to check to see if my number of items is equal to 5. If it's equal to 5, then it's full. If number of items equals 5, then I'm immediately going to return -1 because it wasn't added successfully, because there's no room in the queue. Doesn't matter where the next open index is, it has 5 items. Now, that's one possibility. The other possibility is that we can put it in. So we're going to do our circular queue. What index are we using? We're using where the tail is, which is the end of our queue. What are we putting in there? New record, which was the parameter that is being accepted by enqueue. Now, the next thing we need to do, we need to see if our tail is at the end. If tail equals 4, then what we need to do is we need to reset it back to 0, because remember, this is a circular queue. It doesn't just drop off. If we're at the end, we need to swing around back to index 0. If we're not at the end, then all we need to do is simply increment tail by 1. Once we add it, our number of items increases by 1, and then if we increase the number of items by 1, it was successful, we return 1. All we need to do now is copy and paste that code. So I'm going to go down, make sure I can see it all. Windows, Shift S, bring up the snipping tool, just like we did earlier. I copy and paste that code, or select the code that I want to copy and paste. Get rid of this predefined text here, Control V, and there's my code. Again, on a new page, I'm going to scroll up. It only takes a second. I want to double check, make sure I'm in the right part. I am. It's in 2C. I'm going to make sure 2C2 or 2D is next. It is. So let's go ahead and move on to part 2D. The function dequeue, so removing an item from the queue, returns a null or empty record. Not a null value, but an empty or null record if the circular queue is empty. Because we can't remove an item from the queue if there's nothing there. Returns the first record in the queue if the circular queue is not empty. Because remember, the circular queue follows the first in, first out principle, just like standard queues do. We update the pointers and other variables as required, write program code for the function dequeue. Now, it doesn't mention that it takes any parameters, but it does return a record. So we need to make sure we determine the return data type appropriately. Let's swing over to vb.net and take a look at what that looks like. Now it's time to write a function that will remove items. We call that dequeuing. Doesn't have any parameters, but what is the return data type? Cell data, because it is returning a record. So I'm going to call this one, this record, as cell data. Now it said it could return a null record here. So what I'm going to do is I'm going to do this record dot cell ID equals nothing, and this record dot quantity equals -1. And that way, if it's empty, it will return that record. Now, the first thing I need to do, or what I need to do now, is see if my queue is not empty. So if number of items, not nullable, but number of items, there we are, is not equal to 0, then we know there's something there and we need to start dequeuing it. So I'm going to take this record that I created. What am I putting into it? Well, I'm accessing my circular queue. The index I'm accessing is where the head pointer is, because that shows the next item to be dequeued from the queue, because it works on the first in, first out principle. Now, if I want to remove that, that means my number of items is going to decrement by 1. The next thing I need to do is check if my head position is at 4. If it is, I need to reset my head back to 0, because remember, we are running a circular queue. If we are running a circular queue, we need, when we get to the end, which is our 4th index, we need to swing around back to the beginning. Now, if I'm not at the end of my array, then I need to increment head by 1. Either way, we have the code we need, and I'm simply going to return this record, and that is the cell data type, because this record has been dimensionalized. It will return both of these values, cell ID and quantity, or the cell ID and quantity that is pointing where the head pointer is. So we're going to return this record. I'm going to hold the Windows key, Shift S. That's going to bring up the snipping tool, just like we've been doing. I'm going to highlight the code that I just wrote. I'm going to open up my evidence document. I'm going to paste it in. I'm going to scroll back up, make sure I'm in question 2D. I am. Perfect. I'm going to scroll back down, just quickly glance at my code. I have my function header. I have the end function. We have our return statement. We're ready to move on to the next part of the question. The procedure enter record. So we're not returning anything here because this is a procedure, which means it's going to be a sub. Takes an ID and quantity as input and creates a cell record. So we're not taking it as a parameter inside this inner record procedure. We're actually going to do some taking user input. Uses enqueue to insert the record in the circular queue, which is what we did. We just wrote that function earlier. Outputs full if the record was not inserted in the circular queue. Output stored if the record was inserted in the circular queue. Write program code for the procedure inner record. Copy and paste the program into part 2E in the evidence document. Let's swing over and let's code this out. All right, all I need to do is, and this time, instead of using function, I use sub and we call it enter record. That's the name it gave us. Doesn't accept any parameters. There is no data type being returned, so I don't have anything outside the parentheses. Now I'm going to use this record again as cell data, because what I'm going to do is I'm going to enqueue that record. I'm going to ask the user, I'm going to do console.writeLine, enter the ID, and then I'm going to store that right inside this record.cellID equals console.readLine. Then I'm going to do the same thing again, this time though, asking for the quantity. So enter the quantity, this record.quantity equals console.readLine. That will give me everything I need for the record to set it up. Now I need to try to add it or enqueue it to the circular queue. So I do that with the enqueue function that we wrote. It does take a parameter. it does take this record that I just got from the user, I'm sending that down. Now, if that equals -1, because it's going to return something, then I know that the queue is full. So I'm going to write full, because that's what Cambridge told us to write. If it's not -1, then I know it's got to be 1, console.writeLine, and I simply write stored. So that's going to be everything that we need for the enter record. Pretty short there. Hold the Windows key, Shift S, brings up the snipping tool. We're going to highlight the code that we just wrote. Then we're going to open up our evidence document. We're going to scroll down to 2E. We're going to highlight this, Control V. I'm going to make sure it's in 2E. It only takes a second to double check. I'm just I just want to make sure I'm putting it in the right spot. I want to be careful like that. I have my sub, in sub. It has everything that Cambridge was looking for. So we're ready to move on to part 2F. The following cell records need to be entered into the program. So here they give us a table with a cell ID and a quantity. Amend the main program to. The main program, what does that mean? That means sub main. So we're going to go back to sub main and we're going to add in some code. We're going to use inner record to input the 6 records in the table. Use dequeue to remove 1 record. Output either the ID and quantity of the removed record or an error message if the circular queue is empty. Okay, so we'll do that. Use inner record to input the record with the ID LLP for a second time. Output the ID and quantity for all the records currently stored in the array circular queue. So we're going to need to input LLP again because it shouldn't be stored. Here you'll notice it says to inner record to input the 6 records in the table. Remember, it only holds 5, and they're going to want to see that full message that we just wrote, and we shouldn't be able to successfully add LLP. When we use dequeue, that should output ADF10, and then when we enter the record again, LLP will occupy index 0 because that's where the head pointer will be, or that's where the tail pointer will be. The head pointer will be moved to OOP after it dequeues ADF. The tail pointer was at HQR, but it's going to go swing over to index 0 because remember, it loops back around. That's how the circular queue works. Because we remove ADF, we're going to update that tail pointer when we go to enter the record, and it will swing around. So that is what we are looking for. So we want to pay attention to that when we output it, make sure it outputs correctly. But let's swing over to VB and let's code this out. Okay, the first thing I'm going to do is I'm going to dim this record as cell data, not cell record, because cell record doesn't exist in this program. All right, the first thing they want us to do is do we're going to run a for loop, 1 to 6, and we're going to call inner record. So they want us to do that 6 times to try to enter the 6 items in the data table. Now you may be saying, why did you create this record? Because when I dequeue an item, it's going to return a record. I need a data structure to put that into. Now, the first thing I'm going to do is I'm going to check to see if the cell ID is equal to nothing. If it is, then I know that there are no items in the queue. So I'm going to do console.writeLine. There are no items in the queue. And that was the point of returning the null record. That's how we're going to use it. Now, if it doesn't return a empty value for the cell ID, then I know there's an item that we just dequeued and put in record. So let me get back to my code. So all I'm going to do here, so I'm going to do console.writeLine, and I'm going to output it. I'm going to put ID, and I'm going to use this record.cellID, and I'm also going to output the quantity. So I'm just going to use some string concatenation. This record.quantity is what they wanted. All right, so then they want us, that will dequeue the item, which will free open a spot. So then we call enter record again. This is where we're going to re-enter the LLP cell ID. Now what we need to do is output everything in the circular queue. This is very important. When we output the circular queue, it may not look correct because it should, if we did it correctly, start with LLP. That's because the ADF is inside index 0. When we remove that item, the next open spot in the circular queue is index 0. So when we output this, it's not going to output what it's going to be in order. It's being output how it is stored. So we are going to do for I equals 0 to 4. And then all we're going to do is we're going to output everything. Console.writeLine. Now what we're outputting here is we're outputting the circular queue, not this record. So I'm going to output ID, my circular queue I, dot cell ID, and not only am I outputting the cell ID, but also the quantity. So in circular queue I dot quantity. Okay, that has everything we need. I can't see all my code, so I'm going to change this percentage from 100 to 90. Scroll up a little bit. Still can't see my code. Not a problem. 80%. There we go. Get rid of this extra line here. Just get my code to fit. There we go. I'll be able to see everything. So Windows Shift S. Bringing up our snipping tool. And I'll copy everything. Now this includes code I already wrote. And that is okay. They're not going to be grading the code you already wrote for 2F. What they're going to be looking for here is they're going to be looking for the new code that we wrote. So we're going to scroll down, make sure it's in 2F. There it is. And the examiner will be able to read that without a problem. If I can read it, anybody can read it. So let's move on to part 2F2 and get ready to wrap this question up. Test your program. So it's time to take all the code we just wrote and it's time to test it out. They want us to take a screenshot of the output. So let's swing over to VB. Let's run our code, enter that data, dequeue that item, add in LLP, and then output the entire circular queue. So we're going to start with the table that they gave us, ADF, quantity of 10. This should say stored. It does. Perfect. The next one is OOP, and that is a quantity of 1. That should say stored as well. Perfect. BXW, and that has 5, a quantity of 5. That should say stored. Perfect. Looking good so far. XXZ, that has a quantity of 22, stored. HQR, this should be the last successful one. Has 6 items. It should say stored. Wonderful. When we enter LLP with a quantity of 3, it should not say stored, it should say full. And we can see here it does. Then we run the dequeue code. What is the first item in our queue? Well, it works on the first in, first out principle. What was the first item we entered? It was item ADF with a quantity of 10. Because the ADF, quantity 10, was inside the circular queue, index 0, that is now the next open spot on the conveyor belt. So when I add LLP with a quantity of 3, LLP quantity 3 will be in index 0. When I output the circular queue, it's not going to put the items that are going to be outputted in order. It's very important you understand that. So we should see LLP quantity 3. We should see that first in our output. And we do. Here we have LLP quantity of 3. We don't have ADF 10 anymore because that's been removed from the conveyor belt. It's been dequeued from the circular queue. Because it's been removed, it's an open spot. That's where we put LLP quantity 3. Then we have OOP quantity 1, BXW, XXZ quantity 22, HQR quantity 6. We have all 5 items. Now, here is some advice. If you think it is doing it wrong, then what you can do here is you can copy this code that you wrote temporarily and run some tests. You are allowed to run some tests. So now if I enter this again, if I run this again, we should see it output OOP at the very end when we dequeue it. So I'm just going to enter all this data again. It only takes a second to do. So that was 5XXZ had 22, HQR had 6, and LLP had 3. We can see enter the ID, LLP 3, and there you are. Even though LLP is first inside the queue, notice here this extra line of code that I wrote. Notice it's outputting the second item we entered. Has already dequeued ADF. What is the next item to dequeue? That's OOP with a quantity of 1. So what we're going to do now is we're going to remove this because that's not what they want us to do. So I'm going to get rid of this right here. And we have to run this one more time because we have to take a picture of our output. So not a problem. We worked hard on this. So let's work with our code again. See our beautiful coding skills in action. So we're just going to enter this again. Not a problem. So 22, HQR 6, LLP 3. Move this up. LLP 3. And that is what we have. Now, when I try to take a picture of this, I can't get all of it in there. What do? Not a problem. So what we're going to do is we're going to open up our snipping tool, Windows Shift S, and I'm going to make sure I'm all the way at the top, and I am. And I'm going to copy down right here to where it says full. That's going to be my cutoff. I need to know where my cutoff is. I'm going to scroll down to 2F2. Get rid of this text here. I'm going to paste it in. What I'm going to do now is I'm going to scroll down a little bit and I'm going to move that cursor right into here so I can paste it again. I'm still inside 2F2. Swing back to my program. I'm going to scroll down. Here's my cutoff where I took my last picture. Windows Shift S again. And this time, I'm going to copy everything, including press any key to continue. I'm going to paste that code in. And now I have everything answered for question 2. Hope you guys found this video helpful. If you did, please take a moment to give it a thumbs up and subscribe to help the channel grow. And we'll see you guys in the next programming video.